Now we are going to take a new topic, that is interconversion of states of matter. As I told you in a previous lecture that matter exists in three states, that is solid, liquid and gas, and it will be you'll be surprised to know that these states can be interconverted from one state to another state. And I illustrate an example for you. See, we have ice. Ice is obviously a water, but which form? The solid form. And we also get water. Water is again a form, that is liquid form. And we also get a water vapor that represent the gaseous form. So that means we know, see, water at room temperature it occurs at liquid, but in freezer when you keep it, it occurs at ice, and when you boil it, it occurs as vapor. So that means the water can exist in three states. Now how come the water exists in three states? So that means this show that these states are interconvertible. These states can be interconverted from one state to another state. So how they can be interconverted now? Look, we can convert solid to liquid or liquid to gas or gas to liquid or liquid to solid by altering certain conditions, that is by altering the condition of temperature and pressure. By doing so, we can interconvert these states. So first of all, I would like you to know the phenomena, the name given to the phenomena, that is the conversions. That is, when we convert solid to liquid, it is called as melting, and it occurs at particular temperature, that is melting point. And the conversion of liquid to gas is vaporization. It occurs at boiling point. I am repeating it for you. See, conversion of solid to liquid, the phenomena is called as melting. The temperature at which solid get converted into liquid is called as melting. We need to increase the temperature if we wish to convert solid to liquid. So that means this melting occurs on heating. Similarly, if we wish to convert liquid to gas, the phenomena is vaporization. The temperature at which the liquid gets converted into the vapor is called as boiling point. And again, it occurs on rising temperature, that is on heating. Now, I want you to know that how it can be explained on the basis of kinetic theory of matter. We are taking the conversions only solid to liquid and liquid to gas. So see, we are considering the first phenomena, that is the conversion of solid to liquid. Obviously, when the states are changing, so that means there is a change on the particle arrangement also. So I want that you should know that how that change is carried and what actually is happening, that solid gets converted into the liquid. So see, in solid, particles are arranged in this order. That means they are closely packed. I am again briefing the properties of solid, that is, they are closely packed, their space is too low, intermolecular space, force is very strong, and they somehow possess kinetic energy, maybe because as they possess kinetic energy is little, but still they possess some kinetic energy, and they also possess potential energy due to interaction between the particles. So these are the properties which already a solid has. Now what happens actually that on heating it changes into liquid, that what change is occurring in it, we are going to study that. See, now I am heating it. When we heat it, we are raising the temperature. So what happens? That these particles gain the energy. These particles gains the energy. Then as a result, what happens? When they gain the energy, their kinetic energy increase, obviously. So if the kinetic energy will increase, that means they will now start moving more faster. And when they will start moving more faster, that means they will move far away from each other. And when they will move far away, that means these spaces will increase. And when they will move far away from each other, when the space will increase, it will lead to decrease in the intermolecular forces. And we know liquid correspond to the state when the particles are far, intermolecular space exists more than solid but still exists, intermolecular force low, it exists but lower than the solid. So if when we are heating it, they are gaining energy, they are moving, the space is increasing, force is decreasing, that means it now change into this kind of structure, and we know this structure correspond to the liquid state. So this is how the solid get converted into the liquid on heating. I am again repeating it for you. We are supplying heat, they are picking up that energy, due to which the kinetic energy increase, that means moving faster, far away, space increase, force decrease, and they get converted into the liquid state. So this is how the solid get converted into liquid on heating. This is the explanation based on kinetic theory of matter, that is the conversion of solid to liquid. Similarly, when liquid is converted into gas, so the phenomena is called, as I have told you, a phenomena is vaporization corresponding to the temperature, that is boiling point. The same thing is happening at the same level. See, in liquid particles are like this, little far from each other, there is a space, less force. These are the properties which a liquid already exhibit. Now when we are heating it, they are gaining that energy, due to which the kinetic energy is increasing, they are moving far away, the space is increasing, force is decreasing, and they get converted into the gas. So this is how the same phenomena, that is how on heating solid can be converted into liquid, or how on heating liquid can be converted into the gas. So on the basis of kinetic theory of matter, we can explain by just showing that how they are gaining energy, how they are moving far, how the space is getting affected, how the force is getting affected, and how states are converting from one to another. Now taking into consideration, that is how the states are converted vice versa, that means liquid to solid. See, now we wish to convert these states vice versa. So taking into account liquid to solid. So when we want to convert this thing gas to liquid, we have to cool it, that means by lowering the temperature. Similarly, when we wish to convert liquid to solid, again we have to cool it. By rising the temperature, we convert solid to liquid, liquid to gas, but by decreasing the temperature, that is by cooling, we convert gas to liquid or liquid to solid. So we are now taking an example of the reverse, that is liquid to solid. The conversion of liquid to solid is called as freezing, also called as solidification. Now, and the temperature at which it occurs is freezing point. The temperature at which liquid gets converted into solid is called as freezing point. Now, how it can be explained on the basis of particle matter, on the basis of kinetic theory of matter? Same as we did in case of solid to liquid, the reverse happens for it. See, in liquid particles are like that. There is a space, less force, as I have told you all properties. Now we are cooling it. When we are cooling it, that means energy is lowered. Now when the energy is lowered, that means the motion is somehow ceasing, means motion is decreasing. When the motion is decreasing, that means intermolecular space is again decreasing. When the space is decreasing, they come closer to each other, that means intermolecular force is increasing. And when these all properties happen, that happens in state of solid, where particles are closely related, closely packed, less intermolecular space, more force. So this is how the liquid gets converted into the solid. Similarly, it happens for the conversion of gas to liquid. Same, that is, I don't think that I need to make a diagram again for you, but still I am making you understand the concept theoretically. See, in gas molecules, particles are far apart, they are losing heat, we are cooling it, so that means they are releasing heat. When they are releasing heat, then what happens? Motion cease, the kinetic energy decrease, so obviously the motion cease. When the motion cease, the space decrease and the force increase, and it get converted into the state that is the liquid state. So this is how the states are interconverted from one to the another. You will be surprised to know that there is a phenomena in which we can directly convert solid into gas by skipping the liquid state. I repeat, we have the phenomena in which we can convert solid directly into the gaseous state by skipping the state liquid. And when this gas is cooled, this solid get converted into gas directly on heating. Whenever we proceed in the in a straight line, that is solid to liquid, liquid to gas, it happens on heating. And when we proceed in the reverse, it happens by cooling. So always keep in mind, solid to liquid, liquid to gas by heating, and opposite by cooling. So see, the phenomena I was telling you, that we have a phenomena in which solid can be directly converted into the gas. Again, same on heating. Keep in mind that it occurs by heating. And when this gas is cooled, it again changes into the state that is solid. So that phenomena is called as sublimation. This is an important phenomenon. So what is sublimation? It is a process in which the solid directly convert into the gaseous state. And how? By heating. And this gaseous state on cooling can again form the solid state. There are the special names which are given to these states. See, the gaseous state which is formed is called as sublime. And when on cooling it again forms solid state, that solid state is being given a name sublimate. So sublimation consists of sublime and sublimate. Sublime is the gaseous state, sublimate is the solid state. It's solid to gas by heating, gas to solid by cooling, sublime and sublimate. Now the question comes, can all solid directly form the gaseous state? Can any solid state, any solid on heating can skip the liquid state and can form gaseous state? So the answer is no. Only few solids are there which can directly on heating can form the gaseous state. Now the question arises in our mind that what is special property in that solid that they can directly form the gaseous state and few solids can't. So what is the reason behind? See, look at the board, I am explaining you. These solids actually have the force of attraction not so strong. It is strong but not so strong. So what happens when you heat them? They gain the heat and they are able to overcome their force of attraction. They are able to overcome their force of attraction and escape forming the gaseous phase. So this is the reason that they can overcome their force of attraction. See, when we heat the solid, the force of attraction decrease. But what happens in this case? They overcome the force of attraction and just leaving behind the other atoms or molecules and getting converted into the gaseous phase. So this is how the sublimation take place. We have few examples. You must have seen your mama keeping white balls in the along with the woolen clothes, and after few days or months when you open your bed or see the box, there are no balls found. You know what exactly that balls are? They are naphthalene balls. Those white balls are naphthalene balls. You know why your mother keep those balls with woolen clothes? Yeah, they keep these balls with woolen clothes to prevent those woolen clothes from moth and all, so that they are not attacked by those silver fishes and all like that. So what happens to this naphthalene ball? Our question is this: what happens to the naphthalene ball? Where does this ball goes? Actually, this ball shows sublimation. When you keep that ball, it starts forming the gaseous state. So it just converted, that solid ball gets converted into the gaseous phase, and when you open that box, it gets, you are not able to see that, it vanished. So this is how the sublimation take place. And one more question I would like to discuss with you. It is beyond your syllabus, but still I want that you should know what actually is. See, When we are converting solid to liquid, we are heating, and similarly when we are converting liquid to solid, we are cooling. Similarly, when we are converting liquid to gas, we are heating. When we are converting gas to liquid, we are cooling. So that means there is a special name here. What is that heat? The heating or cooling, rising the temperature or decreasing the temperature. So that the heat which is involved in changing the state is being given a special name, and that name is latent heat. That means a hidden heat. What is the function of this heat? This heat does not rise the temperature of the substance. See, melting point of ice is 0 degrees Celsius. Boiling point of water is 100 degrees Celsius. So, when the water, when you are heating the liquid, when you are heating the water at 100 degree, it changes into vapor, right? So, if I say that when we are heating it, why the temperature of liquid does not rise? The question comes to our mind, listen to it carefully. We are taking a sample of water and we are heating it, but that heat is not actually raising the temperature of the liquid. It is just converting the liquid into gas. So the question comes, why temperature does not rise when we heat a liquid or when we heat a solid? Because that heat is being utilized in converting the state. How? By increasing the force of attraction or decreasing the space, or vice versa. If you take a vice versa example, that is decreasing the space and increasing the force. So that means that energy is utilized somehow in changing the state, that it's solid to liquid, liquid to gas, or opposite manner. But it is not rising the temperature of the sample. So always keep in mind that temperature which you are supplying or the cooling of the energy which you are withdrawing is called as latent heat. That heat is not lowering the temperature of the sample, it is not increasing the temperature of the sample, it is just converting the state by affecting the force and the space of the particles of the state which we are considering.